recurrence relations can be written in the following standard form. And recall our example of the recurrence relation that describes the terms in a factorial sequence, where n was greater than 1 and we had an initial condition of 1. So here we have the terms in the sequence depending on the following previous terms, and these here are known as the coefficients. And on the right hand side we have some function of n. And this here is known as the standard linear form. So by linear, we'll mean the current term in the sequence is linearly dependent on the previous terms. So for example, if you look at the equation of a straight line, y equals mx plus c, then we can see that this recurrence relation is analogous to this equation for a straight line. We'll have the slope being n and the y-intercept being 0. So this recurrence relation is linear. And the other property is whether the recurrence relation is homogeneous. So if we write the recurrence relation in the standard form, we have Sn minus n by Sn minus 1 is 0. So as we can see, the right hand side here is 0, so therefore this recurrence relation is homogeneous. And the other property is order. So this recurrence relation is first order because the term Sn depends on one previous term, and therefore this first order recurrence relation has one initial condition. And the other property is whether the coefficients are constant or variable. So in this case, n is a variable, so this recurrence relation has variable coefficients. Now another example of a recurrence relation that we've seen is the Fibonacci sequence. So we have the current term in a sequence depends on the two previous terms, where n is greater than or equal to 2, and we had two initial conditions. So this recurrence relation is still linear. So if you make the analogy with the equation of a plane, and it's also homogeneous, because if you put all the s terms on the left, we can write the equation as follows. And therefore Gn on the right hand side is 0. And this is a second order recurrence relation because the current term depends on two previous terms, and therefore, because it's second order, it requires two initial conditions. And in this case, the equation has constant coefficients. So as you can see, the coefficients of the s terms are 1. And here is an example of another recurrence relation. So first we write it in the standard form by dividing through by n and putting the non-s terms on the right hand side. So as we can see, Sn does not linearly depend on Sn minus 1 because it's in a square root. So this recurrence relation is non-linear, and g of n is not 0, so it's also non-homogeneous. But the current term, Sn, depends on one previous term, so it's still first order, and thereby requires only one initial condition. And here you can see that this coefficient is a variable. So this recurrence relation has variable coefficients. Please subscribe, like and comment to help me reach more students.